if you want to follow along what I'm doing, take the center hole of the paper, go down about 2 squares, and mark a point. Then count out 10 squares to the right and 10 squares to the left. When you're done with that, you can go ahead and draw a straight line. I hope you brought your reticulated rulers that you got with your line book. Yeah. Take an extra 30 seconds to make sure you draw a perfect straight line. Make this a 10-pointer that you can take 100% of the credit with you. All right. The next thing we're going to do is you're going to get your handy-dandy compass out. Remember that compass?
Yep.
Bring that out. And if it is loose, if it is really loose, just tighten the screw. If you need to tighten it a little bit, let me know. I can help you with it. Okay? Because you're going to have a little bit of a firmness to the arms in order for it to have, good control over it. You don't want it to flip-flop everywhere. So if it's too loose, if you can just kind of snap it back and forth, then let me tighten it for you. Otherwise, we're ready to go. What I would do is I would measure the distance on your compass from one end to the other. Yeah, like so. And once you've done that, then simply bring your lead or pencil part down to the bottom and just make a little sweep, a little arc. That's all you need to do on this side. Okay? When you've done it on this side, then go to the other side and do the same thing. Go to the other side of the line and do the same thing. Okay? There we go. Now you've got your third point. So you draw your triangle, you complete your triangle. You're not going to triangle. Next up.
Oh.
Try to use the graph writers I gave you because they have an extra sleeve on them, on the lead, and that keeps you from smearing. It keeps you from smearing the diagram.
Just the distance from your line.
All right? Any questions so far? Now, the next thing we're going to do is draw bisectors. The first bisector of the triangle is easy. We just simply grab the midpoint of the line and with confidence take it to the vertex, the opposite angle. Like so. Again, take a moment to draw it carefully. Now the question is, how are we going to do the other two halves? Because they're going to need to go to the opposite sides. How are we going to do that? You can't just simply count out the squares here because the line's at an angle. Well, that's not a problem as long as you have your handy-dandy compass, right? You just simply measure the distance halfway, like so.
So,
And
can you erase this line?
we take that half measurement and we just bring it to the bottom and watch. Just make it mark here and a mark here. And now you got your halfway points. With pretty good certainty. Okay? Now you can go ahead and draw your lines, your bisectors this way and this way. And each bisector is going to be automatically 90 degrees. You don't even have to measure it. It's automatically 90 degrees to the line. So these are perpendicular. And if you did it correctly, these three bisectors should go right through the center of the triangle. Like so. You can see no daylight, right? All three lines come to a single point. All right. Now we just simply take this triangle and give it labels and declare it Einthoven's triangle. So it's always the subject's right and left. So this is the right arm, this is the left arm, this is the left leg. Now, what about the right leg? I don't want you to do this on here. You can do it on your little worksheet that has a little mock-up triangle on there. You can mark it on there if you wish, but don't mark it here. The right side is marked this way. This is the ground. That's the symbol for grounding. And we call it RL. Okay? But like I said, don't do it here. Do it on your worksheet. All right? The next thing we're going to do is we're going to establish our isoelectric points, which are simply the center point, 0, 0, and 0. We're going to now show where the eye of the machine is. Where is the machine looking from? From here, it's looking at the heart, it's down on the heart from lead 1. From here, it's looking from the right, and from here, it's looking from the left in lead 3. So lead 1 from the top, lead 2 from the right, lead 3 from the left. And these are called bipolar leads because if it's positive, it's recorded in an upstroke. If it's negative, it's recorded in a downstroke. How do we know what side is positive, what side is negative? Well, just remember that the right arm, no matter what, is always negative. The left leg, no matter what, is always positive. Okay? So if I make the right arm always negative and the left leg always positive, it only leaves the left arm, which has to be positive in lead 1 and negative in lead 3. So go ahead and do that. And now our Einthoven triangle is complete. So go ahead and title it Einthoven's triangle. Okay. Wilhelm Einthoven is the electrophysiologist that invented / discovered EKG. Okay. Now, yeah.
The right leg, is it part of the triangle?
No, like I said, don't put this over here. Put it on your mock-up worksheet. This is how we represent where the right leg lead went, the lead electrode, the skin electrode. We don't use it. We don't use it for Einthoven's. It's not part of the triangle. But it is used to be a ground, okay? Safety. So if you got shocked or if there was a lightning strike, you'd be protected. Okay, so now let's put those numbers down. I'm going to mock up some numbers here. 5, 9, and 4. Okay? Those are the 3 numbers I got. Now, anybody have any huge numbers, like 20, 15, 10, anything like that? Any numbers past like 8? Huh?
For what?
for your height of the R wave. If you got huge numbers, there's a couple of things you can do. One is just good old-fashioned scaling, because you're going to be basically drawing a triaxial graph. So if you only had 10 squares and your largest number was 30, what would you do? You'd make each square count for 3, right? Isn't that what you do when you scale? Okay. All right, that's one way. The other way is you simply take your smallest number and divide it into all 3 numbers. So let's say it was 5, 14, 5, 15, and 10. 5 divided by 5 is a 1. 5 divided into 15 is a 3. 5 divided into 10 is a 2. So your numbers would be 1, 3, and 2. Okay? It's however you want to do it. Okay? Or you can just simply do a scale and just figure out a scale. So in this case, my largest number is a 9. Okay? I can simply go all the way across to 9 if I want to, but do I really want to? Because now I'm kind of approaching the end of the triangle. So what I'm going to do is I'm going to call each square 2. So 5 would be 2.5 squares. 9 would be 4.5 squares. And 4 would be simply 2 squares. Okay? So you figure out what scale you want to use. Now the question is, how do I put these numbers on the graph? Well, here's what I do. For number 5, I'm going to go ahead and simply mark 2.5 and then draw my line. Now, this is where your reticulated ruler comes in very handy. You notice that you got little graph marks on there. I line up the top line with one of these established graph lines, and I will, with confidence, draw a straight line. Okay? Like so. That's a perpendicular line to the top line. Now, how do I draw 9 over here? Okay, I got that same problem again. How do I mark off 9 squares? I'm sorry, 4.5 squares over here. Well, once again, I'll use my compass to help me. I'll mark off 4.5 squares. So there's 4.5 squares, which represents number 9, right? But what I'll do is, I'll bring this measurement over here. And since it is a positive 9, I'm going to mark it in the positive direction. And my next number is 4 for lead 3. So I'm going to measure out my 4, which is basically 2 squares. And I'm going to put it in the positive direction, like so. Right here. Okay? So go ahead and do that. So once you've marked off all 3, all I'm going to do now is I'm going to draw perpendiculars for each of the lines from that point. So I'm going to mark off a perpendicular here. You understand perpendicular, right? 90 degrees?
Yeah.
I'm going to mark off a perpendicular here. Okay? And what I create is should be ideally a point, but it may not always be a point between these 3 lines. I should create a point. This is the apex of the heart. The center of the triangle is the AV node of the heart. So electrically speaking, your heart is sitting like this, somewhere in here. Okay?
What does that mean? Electrically speaking.
Well, because you're doing it all by electric numbers. That's all you have. You just have, these are all measurements of voltage. Okay? Now, let me finish the idea and maybe you'll get it in a little bit. What I'm going to do is I'm going to draw a line